So finally, we hit our last topic of 1-2 methods, and that is calculus. The first part of calculus will involve us exploring rates of change. So let's have a look at this function over here. Okay, it's 3 to the power of half of x take 4 take 4. So it's an exponential function that's been moved around a little bit. All right, well, what can we see about it? Well, what we want to note now and start to talk about is its rate of change, and it's always got a positive rate of change. How do I know? If a graph shows that the y values are increasing as x increases, then we say the rate of change of y with respect to x is positive. Now, at a base level, think about that as like the linear graph, that it's got a positive gradient. This one here has also got a positive gradient for all values of x. Now, the thing that's different about this compared to the linear, recall, is that the gradient here is almost zero. So it's climbing very slowly here, and the gradient here is extremely large. Okay, so it's going to be a large positive value here. So the gradient differs along this line here, depending on where I look on the line, but one thing is true for all values of x, is that it's got a positive gradient for all values of x, because as x increases, so do the y values. Functions can also have negative rates of change, and so here we've got the root function here, and it's got a negative rate of change. That is, as x increases, the y values go down until, I suppose, the function's not defined anymore. Okay, now again, it's the same as this scenario here. It's got all sorts of different gradients along here, like the gradient here is different to the gradient here, but one thing is for sure is that it's got a negative rate of change. Functions can also have a zero rate of change. So if the y remains the same value as x changes, then the corresponding graph is a horizontal line, and we say that the rate of change of y with respect to x is zero. That is, as x increases, y doesn't change at all. Okay, it doesn't go up, it doesn't go down, it stays the same. So the rate of change is zero. It's the same, it's not changing. So where is the rate of change in the graph to the right? Zero. It's when x is an element of between these two values here, -2, 4. Now, don't know whether this example, I think I pinched this from the book, I don't know whether it wants us to go into this, but this is also a rate of change of zero. Now note that we've got a positive gradient going all the way up this, and it's getting smaller and smaller and smaller. Now what happens here is this, recall, is called a SPOI, stationary point of inflection. Right, and what happens is it comes down here and it goes stationary momentarily at this point here, and then continues up with its positive gradient. We're going to say and x is equal to the SPOI point -3. All right, this GeoGebra app is not really recording well when I'm doing this video here, but I implore you to have a bit of a play. So have a play and see what you can do in predicting the function that's going to be made when I pour, or when you pour, fluid into those containers. Okay, so let's go straight to the example. Okay, and so the example is water's being poured steadily into each of these vessels. So what I've got is like a hose or something like that, and I'm pouring water into these vessels here, and I'm pouring water at a constant rate. So what happens is I turn the tap on and I don't vary the speed that the water's coming out at. Now what's going to happen is water starts to fill up here, and it's going to fill up at a constant rate. So if I'm looking at the graph here of the height of the water versus the volume that has been poured in, it's going to increase at a constant rate. So the height is going to change, okay, at a constant rate. When it gets to this point here, what's going to happen to the height? Well, it's going to go up a lot faster, because this is a really thin section of the vessel, of the vase, or whatever you want to call it. So what's going to happen is we're also going to get a constant rate of change here, but it's just going to have a more positive gradient, or a steeper gradient, if that makes sense. All right, let's have a look at this one here. So what's going to happen is that the height is not going to change as quickly down the bottom here, because there's a lot of space here, but as it gets bigger and bigger, the rate of change of height with respect to the volume of water in the jug is going to increase. It's going to get faster and faster. So the way we denote that is we say that it's slow at first and then starts to get faster. Right, and what's going to happen is it's going to get to this point. I'm not really happy with the steepness of that graph. I'm not going to make it go as steep. So it starts to climb, then it gets to this point here, and notice that the rate of change will be constant here. Okay, so it'll be the same as this, except it's going to go straight. Right, so this is going to be linear here. This is still going to be a positive gradient, but it's going to change depending on how much water is being filled into, or how much fluid, water, has been poured in at that point. Right, let's have a look at this one. So it's going to be a rate of change that is at this point here, and then it's going to get slower because it gets wider. Okay, and then it's going to get faster again, and then it's going to go constant. All right, so what's going to happen is it's going to go fast at first and then slow down and then speed back up again. So fast at first, slowing down, so we get a smaller positive gradient there. And then what it's going to do is hit this tipping point here. It's going to start to speed up again. All right, so we're going to go like this. So that should be roughly a mirror image of that one there until it gets to this point here, and then it's going to go constant up. Okay, so this one here is broken into 3 sections. Okay, so this one here, and this one here. We've got 3 sections here, with this being the linear or the constant. All right, this being the variable, but both positive gradients. All right, let's have a look at what happens here. So it starts wide, then it's going to get faster, and then it's going to slow down again, and then it's going to get faster, slow down again, and it's going to get faster, and then it's going to go constant. Right, so it's, first of all, let's do this. So it is going to start slowly and get faster and faster. And it's going to do the same thing, slowly get faster and faster. Slowly get faster and faster. And then linear at the end. That should really join up there smoothly. Right, so here, let's call this like section 1, section 2, section 3, section 4. So this is section 1. This will be section 2 from here to here. This is section 3. This is section 4. Right, in this one here, what we've got, the sketch graphs 1 to 4 show the level of interest of 4 students in maths methods during semester 1. For which student was there a 0 rate of change in interest level for the entire semester? Well, that's this one here, that's graph 2. And what that means, that doesn't mean that they have 0 interest in maths methods. What that means is the level of interest stays constant. Okay, so they were rated at a level of interest of 8 to begin with, and at the end of the semester, they were still 8. Like they were just, constantly enthused by the course, but no sort of roller coaster ride. It was like, just the same all the time. Okay, for which student was there a constant positive change, a rate of change in interest level for the entire semester? Well, that's this student here, that's student 1. Okay, because what happened is that the interest was always changing at a constant rate. So their interest is changing. All right, notice that it is started at 0 here, 1, 2, 3, and it just changed constantly. Describe the other 2 students' interest levels in maths methods during semester 1. All right, so let's look at student 3. All right, so what happened is they started slowly, not very interested, and that rapidly changed. Okay, so notice that the interest level and then their interest level increased at a variable rate. Okay, so it wasn't a constant increase. It's like they got to this point here, and it's almost like an exponential increase. That looks like that's probably logarithms there. Students just saw that and was like, I'm just lapping this stuff up. Okay, right, let's have a look at the roller coaster ride that student 4 goes through. So started interested, if we're saying 7 is interested, and then decreased. Okay, so decreased along here. So what they did was decreased for, let's go 5 months, I think the time is. So it steadily decreased for 5 months. Then it hit the lowest point around 5 months. Okay, whatever that is, cubics, I don't know. And then what happened? And then something happened to spark an interest, and then the student interest level increased. Student level increased at a variable, non-constant rate. Okay, so we can see here, there, that it's increasing there. So it's increasing slowly there, increasing slowly, and it just goes nuts. Sketch a graph showing your own interest level in maths methods during semester 1. Well, naturally, it will start at a very high number. Let's go 100 and just go like, exponential, of course, right? Exponential from there, because this is the best course. All right, so can you please do exercise 16A, all of the questions? You might think, oh, that's a lot. Just have a look at the exercise. You'll be right.